The purpose of this tutorial is to demonstrate how to clean and merge data that you gather from a daily diary design. Now, for this tutorial, I'm going to use R, but what's important here is the underlying logic and operations that you would typically follow when you're trying to clean the data as part of a daily diary design, as well as to merge or join different data files that you might have. So I will be going into the R code and script, but also note that the hashtags represent annotations that I've made, and these help articulate what the key steps are, and think about these as logical operations that you need to follow when you're going through and specifically cleaning and merging daily diary data. Okay, so as you can see here, the first step is to specify a working directory folder. And what I mean by this is just specify a path and specifically a folder at the end of that path that's going to contain all the data that you're going to be working with. Often this comes from our survey platform we're using. Most commonly, survey platforms today seem to use .csv files, which, good news, those are easily read into various types of statistical programs and different types of applications we might use. It's really easy to read these into R too, which is what I'll be doing today. So first you want to make sure that you have that folder set up. So I've already set up a folder, and I've called this folder the daily diary data. It just contains a bunch of toy data sets as well as the file for this R script here that I'm walking through in this tutorial today. And as you can see here, I have it broken down for each measurement occasion, which is typically how you receive the data from these different survey platforms. So for instance, you'll get the data for the morning data for Wednesday of week 1, for example. And then you might get the morning data from Tuesday of week 1, and so on and so forth. And then here's the evening data, and then the afternoon data. So I'm just using these prefixes for morn for morning, eve for evening, afternoon for afternoon, aft for afternoon. And this toy example here has 3 measurement occasions per day. You might only have 2, maybe you have more than 3. And this only has 3 days out of a single week, just for illustration and demonstration purposes. But I also have a baseline data set here as well. And so we'll be working through these. And these are all saved into this working directory that I'm specifying here using the setwd function in R. Many other programs and applications allow you to also specify your working directory as well. So I'm going to run that. I've set my working directory. I've told, in this case, R to find, to look to this particular folder in order to find different data and things that I can read in. The next step is I'm actually going to take this path right here, which is the working directory path that I just set here in R, and I'm going to assign it to an object name using the left-handed arrow operator here. And so I'm just going to call it WD. It's very arbitrary, but the idea is now I can reference that object in the subsequent step here, which is I'm using the list.files function in R. I'm sure other statistical programming software and languages have other similar functions or drop-downs that you can use or commands. The idea is that I'm saying I want the list of file names from this path that's listed within this path or this folder here. And I want only to see the list of names for the files that have a .csv file extension. So that's why I set pattern equal to .csv here. And in terms of all.files equals false and full.names equals false, all I'm saying here is that I want only the visible files to be read. And I don't want the full names in terms of having each file prefixed with its path, because this is going to be redundant in this case because they're all coming from the same path. So instead, I just want the file name. So if I run this, we'll first run this and then run this. You'll see here are all the file names here. And why have I done this? Well, this just makes it easier to copy and paste without mistakes and to reference them. This tends to be fairly specific when you're working in in this type of environment in R. Using other types of platforms like SPSS and SAS, it may be less important for you to, because you might be operating under dropdowns and things like that, where there's less of a chance or an ability to make errors in terms of transposing the exact names of files. But in R, it's important we get the exact names of the files, including case and space sensitivity. Okay, so now that we know that, it's time to move on to step 2, which is to read in the data, which is another way of saying import the data into whatever program you're using. In R, I'm going to use the read.csv function from base R, meaning I don't need a specific package to use this function. And I'm going to assign, using the left-handed arrow operator, each of these data files and read them in as a data frame and then assign them to an object that I can subsequently reference and work with later on. So this is the same thing, and let's say SPSS is just reading it or importing your CSV data and saving it with unique file names. So you can think of these data frame objects as almost like being unique file names in other types of statistical software programs. So as you can see, there are 9 daily diary files. We're going to hold off on reading in the baseline data for now. We'll do that a little bit later on. And so the idea is we're going to read in all 9 of these. Okay. And so now if we just pick a random one, so let's do afternoon. So af.wed.week1, which means the afternoon measurement occasion from Wednesday of week 1. Open that up. And we can see, okay, well, each one of these files has a unique ID or unique identifier variable. And this is just for each, in this case, each row represents a person. Each ID number represents a unique person or a case. And so here we have 10 different people with 1 through 10 unique IDs here. And so this is going to be important later on when we merge and join the data frames, as this is our unique identifier variables. Oftentimes your survey platform will provide a unique ID variable that's just a random sequence of letters and numbers perhaps. And so that might be what you use here instead. But this is just a toy example. Also, we have the date here. So this is important to note. This is the date in which someone completed this. So this is, in this case, is March 18th, 2020. And then there's 3 afternoon variables here. And for afternoon, I just did A underscore as the prefix to indicate that. Again, these are toy data, but hopefully this starts to make a little bit more sense as we work through this. And then if we randomly click on evening, you'll also see, again, we have the same unique ID variable here. See the same people here. You won't, in most cases, have a full 100% response rate, so you won't see all of the same unique IDs in each one of these, because some people won't respond certain days. At least you hope that they respond, but often they won't. But theoretically, we could have all 10 of these people participating at all of these measurement occasions on all days, and for all weeks if we have multiple weeks too. Okay, E underscore represents the evening variables. And here's the date for this. This happens to be the evening of Monday of week 1. So that equates to, in this case, March 16th, 2020, which is a Monday. Okay, so I'm going to close these up. So now that we've read those in, the next step is to do what we call a vertical merge or a vertical join of the same measurement occasion data frames or data files. Okay, and so the logic here is that we're going to stack data files, or in this case, data frames, because we've already read them into R as data frame objects, we're going to stack them vertically. And to do so, we need to make sure that they have the exact same variables in them. So for example, if we want to stack all the morning data frames, let's take a look at here's morning of Monday of week 1. Notice they all have the same 4 variables here, or rather 6 variables. They have the unique ID, the date variable, and then they also have the 4 morning specific variables that we assess these people on. And if we do Tuesday, morning on Tuesday of week 1, we see the exact same variables. And if we do Wednesday, we see the exact same thing. So this means we're good to go in terms of stacking the morning measurement occasions. And it'll become a little bit clearer later on why we're starting by stacking vertically first within measurement occasion, or across measurement occasion rather, so doing morning and then afternoon, then evening. But so I'm going to stack these using the R bind function, which allows us to do a vertical merge. And I've just listed the 3 data frame names. Again, if you're using SPSS or another software program, these would be your data files. So conceivably, you're just stacking them one on top of another. And I'm using the left-handed arrow operator to call this new data frame I'm going to be creating. In your case, and if it's SPSS, you'd be creating a new data file. I'm calling this morning. So this is going to have all the morning measurement occasions in a single data frame. Okay, so I run that. Let's take a peek at it. Okay, so now what you'll see is instead of 10 cases, or 10 entries rather, 10 rows, we have 30 here. And why is that? Well, watch this. So if we sort here, we'll see that, well, now we have the unique ID for person number 1. They now have 3 rows because they have responded to the morning survey on 3 different days, the 16th, 17th, and 18th, which correspond to Monday, Tuesday, Wednesday. Okay, and so that's why we now have 30 different entries or rows here. It's 3 days times 10 unique individuals. And again, we have the luxury of having perfect, complete data in this toy data example here, but you get the idea. So now let's quickly run the other two vertical joins and merges, which are for the afternoon and evening respectively. Okay, so same thing here. Let's click on afternoon. We see that now we have 30 entries, and each person has 3 entries here for each of the 3 days, Monday, Tuesday, Wednesday, and their responses to the afternoon variables that they as part of the survey. Okay, so now that the vertical joins or the vertical merges are out of the way, we're ready for step 4. And this means that typically I would recommend at this point cleaning the data and applying inclusion exclusion criteria to all 3. The daily morning data file or data frame, the daily afternoon data frame or data file, and the evening data frame or data file. Okay? And so what that means is you would clean up this. So if you have issues with values that are implausible, or if you have issues around inclusion and exclusion, so let's say that a common one you actually might come across, let's say with, let's use the evening as an example. So I'll pull up the evening one we just created, is that you'll see that the date here for Monday, for people that completed the evening survey on Monday, it should be 3/16/2020, so March 16th, 2020. However, you could have some people, I would imagine, with an evening survey, depending on what your time frame is that you told people to respond. Some people might not actually respond because they're doing this right before they go to bed until technically on the 17th, the next day on Tuesday. And the reason for that is because once you go past 11:59 p.m., you end up in the next day. But really, for our intents and purposes, that person completed it on the 16th, that measurement occasion, that evening measurement occasion, along with the other people, the 9 people who responded. So what I would recommend, for example, cleaning, if you saw someone here that had a 317 or something like that, but you know that actually they just happened to respond at 12:01 a.m. on 317, and really they were completed this for the 16th, the end of day or the evening of the 16th, in that case you would want to go and clean that up and make sure it said 316 instead of 317. This will become important later on when we reference this to create additional variables. Often when you download from different survey platforms, you will have a time of day. Sometimes it can be, and often a time zone too. So you might have to do some filtering and subsetting based on the time of day and the date to automate this process a bit, so you can automatically convert people that should really have a 316 instead of a 317, for example, in this case. Okay, so make sure you do your due diligence cleaning. This can take a lot of time, in my experience, applying inclusion-exclusion criteria for daily diary designs and for just cleaning up the data in general. So don't underestimate this, and make sure you give yourself enough time to do that. Okay, so once you've done that, you're ready for the 5th step, or step 5, and this is when we're going to do what's called a horizontal merge or a horizontal join. And so in this case, we now have, I'll pull it up here. So we now have just get those out of the way. We have the morning, afternoon, and evening data frames. Remember, we created these by doing the vertical joins or merges, and we just cleaned them, presumably. And so now we need to bring these together. So what that means is that we need unique ID. We need the person number 1, okay, with the unique ID number 1. We need to combine their responses across these days, across these dates for the morning, afternoon, and evening, okay? And so we're going to do a horizontal merge or join here. So we're going to join these together horizontally, and we're going to do so by using the unique ID and the date variables as our key or our matching variables here. Okay, so there's 2 unique pieces of information we need to match people up on. The first being their unique ID number. So make sure that person number 1, only their responses appear here. But we also need to say, since they responded on 3 different days, we also need to specify the date as a matching variable or a key variable as well, to make sure that their person number 1's response on March 16th in the morning and the afternoon and the evening are all on the same row, okay? So you have to do this, typically this is a multi-step process if you have 3 or more data frames or data files that you're going to be doing horizontal merges on. If you just have 2 data files, you just need one step here and you just do one merge or one join. Okay. And so here in R, we're using the merge function from base R. And the first thing I'm going to do is I'm going to merge the morning and the afternoon data frames by putting those as the first 2 arguments in the function here. And then I'm going to use the by equals argument to specify, and then followed by the C function, which is the combine function where we can create a vector. We are going to note the 2 key variables are matching variables. And these are how we want to merge and join to make sure every row is appropriately matched here. Okay. And so it's the unique ID variable, which is this, and the date variable. And then the final argument, and I do recommend doing this in whatever platform or statistical software program you're using, is to do what's called a full join, meaning you keep all rows for all people during the merge, and you're not reducing it to only those rows for those people that have data. Okay, and the reason is this: later on during your analysis, you can decide whether you want to apply different types of missing data techniques and so forth. It gives you more flexibility down the road, and also it just retains kind of more of, gives you a better sense of where there might have been missing data and things like that too, and the amount of missing data you might have if that's the case. Okay, in R, you just do all equals true to specify a full join. Okay, and in this case, I'm going to name this merged data frame, or in another program, this might be called a data file. I'm going to call it daily. And the reason I'm doing that is because I'm going to reference it again in the second step. So in the second, so let's go ahead and run that here. Okay, if I click on daily, you'll see that now I have merged the morning and the afternoon, and we can see that person number 1 with unique ID number 1, and on March 16th here, that their morning and their afternoon's responses are all lined up there on the appropriate row. Okay. So the next thing I'm going to do is feed this data frame object daily into another merge. And so logically, what you would do in another program where you're using separate data files is you would take whatever you created here in terms of the merge and then merge that data file with the remaining, if you do have a remaining data file for a measurement occasion, in this case it's the evening data, merge that together. We're going to use the same key variables and matching variables. And this is really important, so make sure that if you need to use multiple matching variables and key variables, that you do that in order to have the right level of specificity so you don't get redundancy built into your data. And what we're going to use, the other arguments will all be the same too. And we're just going to overwrite using the left-handed arrow operator here and just call this daily once again. And so now let's check out the updated daily data frame. And now you can see that we have everything mapped out where we have the morning variables, the afternoon variables, and the evening variables all in one data frame. So that's awesome. So we now have a data frame that is completely merged and ready to go, but we don't stop there. Step number 6 is that I highly recommend that you create some additional variables that provide more information about the day of the week, the week of each observation, as well as the day number cumulatively. And I'll show you what that means in a second. I'm going to access the dplyr package here, which is a part of the tidyverse of packages in R. Basically, it's just a data management set of functions here that reside in this package. And that's going to come out in handy later on with a mutate function I'm going to use. So the first thing that I'm going to do, and this is fairly common in a lot of statistical programs, software programs from my experience, is that dates are notoriously hard to read in correctly, and often you have to specify a date variable as a date variable in order for it to be read as a date variable. In our case here, if I go down and I just type in str to get more information on the structure of the data frame, including the different data types each variable has, and I type in daily, which is the name of that data frame, you'll see that the date variable is not actually of type date. It is actually a factor here. So it's not read in and interpretable as a date just yet. So what I'm doing here is I'm using the as.date function from lessr along with the as.character. This often helps. Sometimes there's some issues if you don't nest these two functions like this. And I'm just saying the date, I just want to make sure this date variable becomes an actual date variable of type date, okay, and not as a factor, which is what it defaulted to. And here's just a generic format for the date, month, day, year, and so forth. It'll actually read out backwards when you see this. But this is the structure that we have the data in currently. If you look at it, is month, day, year. Okay, and I'm just going to overwrite the existing date variable from the daily data frame. So click run. And if you look at the daily data frame, see the format has changed slightly, but the dates, it still means the same thing here, but now it's of type date. So if we rerun that str function here with daily, you'll see that now date is of type date here. So that's good. Okay, so we can reference it as a date, which is helpful. Okay. So the next thing that we're going to do is we're going to create a new variable that is going to be a character or string date descriptor. Okay, and so actually I'd probably better call this day rather than date, because we're going to specifically be talking about day of the week here. Okay, and so first I'm just going to say I'm going to replicate the date variable and call it, plug all the values into a new variable that I'm going to call our day variable, which we don't currently have. Okay, and attach it to the same data frame. So I'll do that and watch what happens if just when I do that by itself, and you'll see that here we have a new data frame with our new variable in our data frame with identical values to the date variable here. The next thing I'm going to do, and I'm not going to get it too much into the weeds in this, is that I've applied the mutate function with the if-else function here. And I'm basically just saying that if the day variable is equal to this date, which is Monday, or rather March 16th, 2020, it's going to be Monday is what we're going to replace that value with. So this value right here for the date will be replaced with Monday in this variable. If it's not that, then we do a nested if-else function. And if it's not that, but it happens to be this, so the 17th of March, then it gets a Tuesday. If it's not that, we use another if-else, then it becomes Wednesday here. And for all else, it becomes whatever the original day variable or value was for that variable that we created. And if in this case there isn't anything else, so it won't have anywhere else to go. But if it did have additional days in the week, then it would just stay as the date or some version of a date variable for those particular values for those cases or observations. Okay, so just mutating this here. All right, so take a look now. If we go back to our data frame, now you'll see that, okay, March 16th, 2020, which is a Monday, it is now appropriately a Monday. The 17th, which is a Tuesday, it's listed as Tuesday in the day variable, Wednesday, and so forth. Again, this is going to be nice for referencing later on, and you'll actually see this play out in just a second, but it is a very useful thing for sorting through your data too, when you can sort by date, day of the week, and so forth, because if you have multiple weeks that people are participating in this, so they might have multiple Monday observations in the morning, for example, afternoon and evening. It's nice to be able to sort all those together sometimes. Say like, well, what do all the Mondays look like across weeks? Okay. And then the next thing is I'm going to create a new variable that this is going to be, I'll call it the week descriptor variable, meaning that we also want to reference for each row what week those data came from, that they were collected. Okay. And so this is going to follow the exact same logic as I did above, just a little bit shorter here. I'm pretending like we have a second week here, just in case that's something that you do have multiple weeks to your daily diaries design. And then note that here I'm using the logical and here, represented by the ampersand, to essentially get a range of values here. So I'm saying when the week variable that we create here, so just like we did before, you'll see here's the week variable. Now it has the date because we just plugged in the values from that date variable. Now we're going to replace them with week values. When the date is between, so you can see here, greater than or equal to March 16th, 2020. And when it's between that and less than equal to March 20th, 2020, which is a Friday, then it's going to be called week one, and then so forth and so on. So same logic as we used above here for that day descriptor variable. So I'm going to run this chunk here. We replace it, and now you'll see we can reference the week. In this case, it's going to be a constant because this was only a 1 week study, but you can imagine how you could extrapolate this if you had more than 1 week of data that you were collecting for the same group of participants. Okay. All right, so now we have 2 reference points here. We can reference not just the date, but also the day and the week, okay? Which is kind of caught up here in this date variable, but this just adds a little bit more level of specificity. Okay. And then finally, I also recommend adding a numeric day number variable, and this is a cumulative day number variable. We only have 3 days here, so it'll just be Monday is 1, Tuesday is 2, Wednesday is 3. But if you were to have multiple weeks, this is a nice way. So instead of Monday of week 2 being 1 all over again, you would make it 6, if you assuming you're collecting data on Monday, Tuesday, Wednesday, Thursday, Friday of each week. This way you can see, track, and reference specifically which day and sequence throughout, let's say, a 2-week data collection do we have respondents data. Okay. In this case, this is where I said these 2 variables I just created, the day and the week variables, come into play. I'm going to reference and say, again, using the logical and operator here, and other statistical software programs also allow you to use the logical and or, less than, equal to, and so forth. And what I'm just saying here is when the week variable is equal to week 1, and logically when the day variable is equal to Monday, then we'll call that 1. And then we'll move on through here, 1, 2, 3, and down the list. Okay. Oh, and here, this is just saying that I want a new, when you run this by itself, you'll see that we should see when we run that, update this. Okay, so there we go. So let's now apply these 3 lines here. So we're going to create the day number variable and the values. So let's click run. Okay, and so now we'll have a new variable here at the end. And so it's just day num, and it just has the sequence of days in which this occasion, this measurement day occurred. Okay. And I'm actually going to delete this right here because we don't need that as part of our script. Okay, and then the next step, step 7, is going to be to let's now focus on bringing in that baseline data. Okay, so we've been working on the within person data, so those daily measurement occasions, and now it's time to focus on the person level data that come in the baseline survey. So we typically would consider these to be time invariant variables. Maybe they're assessing things that are traits or demographic variables and things like that about the people or the participants in our study or data collection. So I'm just going to use that read.csv function. I'm reading in the baseline.csv data that come from this same working directory. Here they are. And I'm going to use the left-handed arrow operator to call this data frame, or in another program you might call it a data file, called baseline. And so here you can see it appears in our global environment in R, and here are the baseline variables, which are prefaced by a B underscore. And then we also see the unique ID variable here, which has the same 1 through 10 values as you would see in the daily diary data or the day level data as well. So the next step is you would want to also clean the baseline data, apply any inclusion, exclusion criteria that might be applicable. And then the final step, step 9, is that you're going to do a horizontal merge or join between that merge daily data frame that we created, that we called daily right here, with the baseline data frame that we just read in and cleaned and so forth. Okay, so we'll use that merge function again. Again, we're merging these together. In this case, we're just saying there's one key variable, one unique variable, and that is the unique ID. This is how we're going to match people up. And so basically, even though someone is going to have, let's say, ID number 1, so this person, unique ID number 1, they, along with everybody else, they're going to have some replication here or redundancy when it comes to the baseline data when you merge it in, because you're going to have the same baseline values repeating for all instances of person number 1's observations here. Okay. All right. So this we're going to call, and we're going to do all equals true. This is again a full join specification here. I highly recommend that you do a full join or a full merge in whatever program you're using to retain essentially all aspects of the data. And I'm just calling this data frame combined. In another program, this might be your data file, your final data file that you plug in to the same program for additional analyses, or then export to another program or platform for additional analyses. So let's go ahead and run this. Okay, so now you'll see the combined data frame appears in our global environment here. Let's take a peek at it. And so now you'll see we have the unique ID variable for person number 1. There are 3 days of measurement we have, Monday, Tuesday, Wednesday, which you also see reflected here, Monday, Tuesday, Wednesday of week 1. And now we have their baseline data integrated or merged here and matched to them. And here's what I mean by that redundancy I was talking about. See that they have, for baseline variable 2, this person has 888, their same score because they only took the baseline once and it's time invariant. So it's going to be the same constant value across all 3 days that they participated in. You'll see that repeated, same with variable 3, 4, 5, and 1. Okay, so that is the logic and the typical operations that you would apply when you're trying to clean and merge or join daily diary data that comes from a typical survey platform such as Qualtrics. Again, I can't underestimate, or I can't underemphasize rather, or maybe the appropriate way of saying this is I don't want to underemphasize how important the cleaning phase is and how much time this will take. So give yourself plenty of time to clean the data, especially when you have timestamps and specific windows people are supposed to be responding to. Look at it very closely. Look for outliers. Look for people that might be, look for duplicates too. So for people, when it comes to cleaning, people who have maybe been allowed for some reason or another to complete the same survey at the same time on the same day multiple times. So be on the lookout for that as well. And that's where you can flag things like seeing the same unique ID at multiple time or at the same time point in multiple rows. Okay. And then the merging and joining, this is really where the bread and butter is in terms of bringing it all together so you can have a data file, a data frame, a data set that you can actually analyze. All right, well, this wraps up this brief tutorial on daily diary data cleaning and merging. Thank you.